Yes, dear students, here is very good question again from NCRT book. For better understanding, you can see this is example 2.2820. 2.20 is this example of NCRT book. Here we have two conducting spheres of radius R1 R2, where R1 greater than R2. They are connected by conducting wire and have charges Q1, Q2. Have charges Q1 and Q2 on them, connected by a conducting wire. So you are asked what is the ratio of electric field on the surface of two. Find this ratio. What is this? And use this result to explain why the surface charge density of a charged conductor is higher at sharp and pointed surface. The conductor may be of irregular surface where it is it is sharper like this. Their charge density higher. Why? So first of all, we have to find out ratio of electric field. Now, what do you think about this? When two conductors are connected together, they have different shape and size, so they have different charge. Then how to find ratio of electric field? Because we can't say here that the charge on here gets centered. We can't apply that fact because this is connected with this also. So when two conductors they have different charge on them and they are connected, they become one conductor, and at surface of one conductor potential remains same because charge is not flowing. Electric charge flows from higher potential to lower potential. You know it from very beginning. In class 8 it is taught electric potential is the cause of flow of charge from one conductor to, like heat flows from higher temperature to lower temperature, the same way electric charge flows from higher to lower. But here charge are fixed. It means potential is same, and we know that potential at surface of a charged conductor, charge sphere, is given by V equal to 1 upon 4 pi epsilon 0 Q upon R. The potential at surface of two spheres is same because charge is not flowing. It is in static condition. So we can write here since charges on two spheres are in static condition. So electric potential at surfaces of two are equal. That is, क्या भाई, 1 upon 4 pi epsilon 0 Q1 upon R1 is equal to 1 upon 4 pi epsilon 0 Q2 upon R2. From here we get Q1 upon Q2 equal to R1 upon R2. Q1 upon Q2 is equal to R1 upon R2. And further we also know that if we have a charge conductor sphere, then whole charge appear at center. So electric field at surface E1 1 upon 4 pi epsilon 0 Q1 upon R1 square, and E2 1 upon 4 pi epsilon 0 Q2 upon R2 square. This is your right hand equation 1. So, what is E1 upon E2 from here? Dividing this by this, E1 upon E2, Q1 upon Q2 into R2 square upon R1 square. You know that? No, sorry, put over. R2 square upon R1 square. But Q1 upon Q2 is equal to memory. Putting this value of Q1 upon Q2, we get R1 upon R2 into R2 square upon R1 square. So E1 upon E2. E1 upon E2 is equal to R2 upon R1. This is the ratio of electric field at surface of 2. Since R2 less than R1, so E1 less than E2. While the two conductors are at same potential, but electric field at the surface of conductor of bigger radius is smaller. So E1 less than E2. That is electric field at surface of sphere of bigger radius less. Further, he is asking why the charge density at sharper edge is maximum. We further know. We also know electric field at surface of charge sphere, और charge sphere कह लो, charge conductor और charged conductor is equal to sigma upon epsilon 0. What is sigma? Surface charge density. Surface charge density. What is that? What is surface charge? Charge per area. It is called charge per area. Therefore, E1 upon E2, sigma 1 upon sigma 2. Since E1, since here E1 less than E2, so sigma 2 greater than sigma 1. So charge density of sphere of smaller radius is large while they are at same potential. I told you earlier also, if we have a conductor like this and it is giving charge, that remain at rest. And you were asked for an example in the book, was there, what the shape of field lines. So here this is sharp edge, here it is flat portion. Since charge is not flowing here, So potential is same. These two systems are at same potential. But electric field is higher than bigger at shorter is bigger than larger the radius, flatter the surface. Our earth is spherical but appear flat because of large radius. Larger the radius, flatter the surface. And therefore surface charge density will be higher at sharp edge. What is my aim to tell you this question? Actually, a science student should be a good observer. He should observe what is happening around us. You have seen taller buildings are fitted with lightning conductor to save from harmful effect of electric charge. When thunderstorm is there, we say light falls from the sky to the ground, and that creates trouble. If that falls on building, then building is destroyed. I have seen here in our neighborhood, in thunderstorm, lightning fall was there, and the gummad of the temple was broken. Then we use sharp edge conductor on the top like this. ऐसे बनाते हैं कंडक्टर को sharp edge. Why the edges are kept sharp? And this is the control. When I was child, I was taught that this is lightning conductor. Then why it is in the shape of Trishul? It was my question. But I could not understand at that time because we were not known this. At sharper edge, electric surface charge density is higher than flatter one, and higher the surface charge density, greater the electric field. Higher the surface charge density, so sharper the edge, higher the surface charge density, greater the field. And hence, whatever charge is produced in the sphere due to friction in clouds, that will induce here positive charge because clouds have negative charge, and that induction will produce strong field. And every charge exchange force F equal to QE. Stronger the field, greater the force. So the whole charge come to this sharp edge, not on the flat part. Suppose on the roof of the building there is a sheet of iron, that is good conductor, but charge does not fall on flat sheet because electric field weaker than these parts. I think you might have got it. Today I have told you in first video concept of mole. That mole means 6.0 10 to the 20, which is called Avogadro number. So generally we will say 6.02 3 10 to the power 23 atom of an element is 1 mole. But this is difficult to count. So I explained you the concept of mole in terms of gram molecular mass. Similarly, I tried to explain you why lightning conductor has sharp edges at the top of building. It is connected to a conducting wire. So whatever the charge developed here, negative charge, that will produce positive charge, and due to induction of charge, electric field is produced. So charge flows to this. Here is a negative charge. In the cloud there is negative charge. So please try to understand the basic facts. Actually, we people are involved in solving difficult numericals, and we forget basic funda of the subject. So this is one problem here. Now there is a question in our book, simple one. Now I come to some simple question here. In our book there is a question here. Okay, 2 point charge is 8. 8 into 10 to the power minus 8 coulomb plus positive charge, and negative how much? Minus 3 into 10 to the power minus 8 coulomb charge are placed at distance of 16 centimeter apart. 16 centimeter is the distance between suppose point A and P. At which point or points on the line joining the two charges potential 0. So potential due to point charge at distance q by r. If the point may be here somewhere or outside this also. Why? Because this charge negative and smaller magnitude of this. So suppose first of all we take point P at midpoint at distance x from A. Then this distance will be 16 minus x. So we know V equal to 1 upon 4 pi epsilon 0 q by r. So their sum is 0, means their magnitude are equal, and hence 1 upon 4 pi epsilon 0 8 into 10 to the power minus 8 upon x is equal to 1 upon 4 pi epsilon 0 3 into 10 to the power minus 8 upon 16 minus x. For centimeter there is no need to convert, because if you convert them into meter square, cancel them. Power cancel. This cancel. 8 upon x. 3 upon 16 minus x. Cross multiply. 3x. 16 is 128 minus 8x. It is how much? 11x. 128. X equal to 128 upon 11. 11 1 11 6 11 5 and 5 this centimeter. This is the point here from 11.56, you can say nearly 11.6 centimeter. Now a point taken here, P dash, at distance x from this. Now in second case that potential is 0 at point P, which is at distance x. Then 1 upon 4 pi epsilon 0 8 into 10 to the power minus 8 upon 16 plus x is equal to 1 upon 4 pi epsilon 0. हमें दिखा है और into 3 into 10 to the power minus 8 upon x. All cancel. So now thing is there, 48 plus 3x equal to 8x. So minus 3 here. So 5x equal to 48. X equal to 48 upon 5. 5 9 is 45. 5 6 is 36. So 9.6 centimeter away. So when some question is asked like this, please read that carefully. Otherwise you will be in trouble. Sometimes you are asked about electric potential and you keep on thinking of electric field. Because electric field is give more trouble to you. So you keep on considering electric field only. So please listen the question carefully. The more question will be done in next video. Thank you.